Okay, before we do this, sine is an odd function. That means if you plug in negative x into sine, that's the same thing as taking the negative on the outside, multiplying the outside of regular sine of x by -1. Cosine is even though. Cosine of negative x, that's the same thing as cosine of x. Notice there's no negative sign on the outside. And tangent is odd, okay? Tangent of negative x is negative tangent of x. So we'll use that here. We've got tangent of theta. We're trying to simplify. And I like to put everything in terms of sine and cosine first. It's not necessary. There's other ways of doing it. But cosecant of negative theta, that's 1 over sine of negative theta. I haven't used those odd and even properties yet. Just putting in terms of sine, cosine, then multiply it by cotangent. Cotangent is cosine over sine. If you haven't seen that before, oh shoot, well, I broke my own rule. I forgot to change tangent into sine and cosine. Yeah, but cotangent is cosine over sine. And then tangent is sine over cosine. So I had to take the negative. Oh wait, there's no negative on these, sorry. These are just sine of theta, not sine of negative theta. Okay, so whenever we try to simplify trig identities, it's usually useful to change everything in terms of sine, cosine. Nothing cross cancels because we have sine of theta and sine of negative theta. So let's use those odd and even properties. We got sine of theta. No odd or even properties apply there because it's currently already a positive theta. Now down here in the denominator, I'm going to move that negative theta to the outside. Make sure you multiply that if you multiply across the denominator. And then here we said cosine of negative theta, that's the same thing as cosine of theta. Sine of negative theta, that's negative sine of theta. Because if you have sine of negative x, that's negative sine of x. Now we have some things that are going to cancel out. Let's note that we can take care of the negative signs right now because a negative times a negative makes a positive, so let's get rid of that. We got cosine and cosine cancel, sine and sine cancel, so we're left with 1 over sine, but that is cosecant, right? Those are both the same thing. So with options here, this is our best option. So simplifying this one, remembering that tangent is sine, I'm going to write negative x, even though it's theta. Just because my handwriting's bad with this mouse. It's bad in general. It's not just this mouse. We got sine of negative x over cosine of negative x. Secant, that can be written as 1 over cosine of negative x. And then cotangent, that's cosine of negative x over sine of negative x, because cosine's the reciprocal of tangent. Cotangent is the reciprocal of tangent. Ooh, okay. So applying those even and odd properties, sine is odd, so that means you can write it without a negative sign on the inside if you put a negative sign on the outside. Cosine's even, so that means cosine of negative x is the same thing as cosine of x. Cosine is even. Cosine's even. And then sine is odd. Okay, now let's see what we can cancel out. Final answer is going to be positive, right? Because negative and negative make a positive. Negative divided by negative. And we have these sines cancel out, these cosines cancel out, so we're left with 1 over cosine, which is secant, and we'll put the theta back in there. So that's this one all simplified.